Hello, my wonderful students. This is foldable number 2 for perimeter and area in the coordinate plane. The first, which is funny because the first two we're going to do here are actually not on a coordinate plane, but I needed to use them because we are going to be doing some crazy ones later on. So the first one, it says find the area and circumference of each. Notice that it doesn't say perimeter because the perimeter of a circle is the circumference. So we're going to go ahead and, what happened there? Is that pen? That is pen. Oh. So we're going to go ahead and use, we're going to find it using the circle with the radius of 12 meters. So we're going to go ahead and, so remember radius is the distance from the center point to the outside. It doesn't really matter where we write it. I'm just going to prove that by just putting it over here. Because like I said, it doesn't really matter. As long as we start in the circle and touch to the end, it doesn't really matter. So this is going to be 12m. So that means our area, if you guys remember the formula for area, I guess I write them both down. Area is equal to pi r squared, and then our circumference is equal to either d pi or 2 pi r. So since we're using r, we're just going to go ahead and use this formula for the circumference. But first things first, go ahead and do area. So we have our area is equal to pi times our r, which is 12 meters squared. So we're pretty much done. We're just going to go ahead and write this in the front. We can go ahead and leave pi as pi. So we have 12 squared would be 144 pi meters squared. Remember, the meters also get squared inside. And whenever we're dealing with area, we always have squared. And whenever we're dealing with volume, we always have cubed because it's three-dimensional shape. This is 2D, so we have squared. All right, so that is our area. Now we're going to go ahead and look at our circumference. Once again, since I said we had our radius and not the diameter, we're going to go ahead and use the formula there. So we have is equal to 2 pi times r, which is once again our 12 meters. So then we just go to multiply. We have 12 times 2, which is 24 pi meters. Okay, moving on to the second one here. We're going to use the same formulas. So we're going to go ahead and find our diameter first. But this one has a diameter of 12. So we're going to go ahead and write it. Once again, it doesn't really matter which way we draw the diameter. It doesn't have to be straight across. So we're going to go ahead and draw it at an angle. Oh, I did a green by accident, which is fine. Which is 12 meters. So in order to find the radius, so the diameter is all the way across the circle that hits the center point. It can't just be a line anywhere there. That's called a chord. But the radius is only half of that, right? Because it's only half of the full distance. So that means we know that our radius for this one is going to equal to 12. Or sorry, the diameter is 6. Going to equal to 6. Diameter is 12. So half of that is going to be 6. So we can go ahead and rewrite another line here. Let's go ahead and just put it right here in blue, I guess. And we know that this is 6 meters. So now we have our diameter and our radius. We're going to go ahead and find the area now. So remember the area was equal to pi r squared. So we have our r now. So we're going to do pi times our r, which was 6 meters squared. So once again, we're just going to go ahead and multiply this, or sorry, square it, or multiply it by itself. Would be 36, 6 times 6, pi first, and then our meters squared. And for the circumference, we're actually going to use the second formula there now. So we actually have our diameter. So we're just going to actually plug it in. So we have c is equal to the diameter, which is 12 meters times pi. And we're just going to rearrange it for math purposes. So we have 12 pi m. M.